My name is Jake Crimmins. I'm a world champion overclocker, and today I'm going to show you how I run my graphics cards on liquid nitrogen. Here's a list of supplies and components I used. Kingpin Tech 9 GPU pot, Vaseline, a heat gun, a propane blowtorch, Gelid Extreme thermal paste, and a Fluke 51 thermometer. For the system, I used an Intel Core i7-3960X processor, an Asus Rampage 4 Extreme, an EVGA GTX 580 classified, an EVGA EV bot to set the voltages, Corsair Dominator GTX 8 memory, a Corsair AX1200 power supply, and a Corsair Force GT SSD. I'm using an EVGA GeForce GTX 580 classified graphics card. I've already removed the stock heatsink and cleaned off the thermal paste. I'm preparing this card by giving it a thick coat of Vaseline. This will help prevent condensation causing issues with the graphics card. I apply the Vaseline to both the front and the back of the graphics card. After the Vaseline is applied, I use a heat gun to warm the Vaseline up. This allows the Vaseline to liquefy and get into all the small spaces between components on the card. You want to avoid heating the Vaseline too much because it will run off the card. With the Vaseline applied, we can go ahead and apply the thermal paste to the GPU. You want to make sure you didn't get any Vaseline on the GPU itself. If you did, make sure to clean it off before applying the thermal paste. I apply the Gelid Extreme thermal paste and use the included spreader to make sure the center of the GPU has an even coat of thermal paste. Now we can install the card onto the Kingpin Tech 9 liquid nitrogen pot. The pot has already been insulated with 1/2-inch closed-cell foam. While applying pressure in the center of the GPU, the 4 thumb screws are tightened down. This ensures good contact is made between the GPU and the pot. With the card installed on the pot, we can get the rest of the system ready to go. After installing the card and plugging in the power, we're ready to fire the machine up. We can now start to pour the liquid nitrogen and get the graphics card cold. When the graphics card reaches around -50 degrees Celsius, we hit the inside of the GPU pot with the blowtorch to create a layer of frost. This frost acts as a buffer, keeping the GPU cold even under the heaviest overclocks and loads. While we get the GPU colder, I run 3D Mark 11 to make sure the GPU does not get too cold too fast. This can cause problems later on with overclocking the GPU. With the GPU below -100 degrees Celsius, I use the EVGA EV bot to set the voltages required to overclock the graphics card. Other manufacturers use software to let you set the voltages. With the voltages set and the GPU temperatures below -120 degrees Celsius, I go ahead and set the card clocks using MSI Afterburner. You may find that setting the card clocks too high at first may cause the benchmark to crash. If this happens, you can start off with a lower frequency, run the benchmark, exit out, and then raise the frequency. I started off at 1272 MHz and then was able to walk the card up to 1350 MHz. 3D Mark 11 completed with the CPU at 4.76 GHz and the GPU at 1350 MHz. This gave a score of 10,694 3D marks. With the GPU at stock clocks, the configuration scored just below 7,000 3D marks. Thanks for watching, and if you want to learn more, you can read my articles on the Corsair blog or check out these overclocking forums.